Okay, this video is on lesson 6.5, exponent rules and nth roots. So part of today's lesson you should be familiar with. We did a little bit of it last semester, but you saw most of this in Algebra 1. So we're basically going to be simplifying expressions that have exponents, and what's going to be new to you today is exponents that are fractions. That's why we call them nth roots. Okay, so recall here that a to the n, where a is your base and n, which is your exponent. Okay, so we're going to go through these properties. Again, most of you, I said you should be familiar with these. This is what's called the product of powers. So if I had a to the m power times a to the n power, remember when you're multiplying things with the same base, you added the exponent. So this became a to the m plus n. So an example would be like if I had x to the fifth times x to the second, you would, since they have the same base, when you're multiplying, you would add the exponents, making that x to be 7. Quotient of powers is, quotient being division, is if I had like a to the m over a to the n. In dividing things with the same base, you subtracted your exponents. So it was m minus n. So same example, if I use x to the fifth over x to the second, you would subtract the exponents to whatever the higher side was, and that'd be 5 minus 2 is 3. Okay, so you can use the same example, and just when you do division, you would subtract your exponents. Power of a power means that you have an exponent to another exponent. So if you had a to the m to also the n, when you had this, you would distribute the exponent, meaning you would multiply. So it would be a to the m times n. For example, if I use the same ones, if I had x to the fifth squared, I would multiply these. It'd be x to the 10th. Power of a product. So this is where you had a power of things being multiplied. So if I had, multiple things in parentheses to a particular power, that power would have to go to both of these. So ab to the m would be like a to the m and b to the m. You would distribute to both of those. Okay? And so example would be if I had like 3x squared, to the third, that third power would go there, the third power. So that would be actually 3 to the third, which is 27, and then you would multiply those, and it would be x to the sixth. Okay. Power of a quotient. So this is the power of things being divided. So if I had, instead of a times b, I had a divided by b to some power. Same thing as power of a product, you would just distribute the exponent across to the fraction. So it'd be a to the m over b to the m. So an example, could be like 5 over x, squared, something like that. Or that squared would go here, the square would go here. 5 squared would be 25, and then x squared would be x squared. Okay, so these are all rules that you should already be familiar with. You should already know what you're doing with these. We did them in Algebra 1. We did some of these last semester. These are going to be assumed that you know what these are. Zero exponent means anything to the 0 power Hopefully you recognize this. Anything to the 0 power other than 0, I should say that. 1, 2, 3, 4, 5 million to the 0 power is 1. Okay, so we can use an example like x to the 0 power be 1. And then negative exponents. This is going to be important because this is the part where kids tend to get caught up with, is negative exponents. If I have some value to a negative exponent, remember what you do. You bring it to the bottom of a fraction so that the exponent can become positive now. You basically invert it or put it over 1 or under 1, and that makes the exponent positive. We cannot have negative exponents in our answers. So if you have negative exponents, you just bring them to the other side. Now it could go vice versa. So if the negative exponent was on the bottom of the fraction, you would bring it to the top. And you'll see the example here. Like if I had x to the negative third and then y to the negative second, these would have to switch sides of the fraction so they become positive. Y squared over x to the third. And so those are your exponent rules. Those are what you should already be familiar with. Now we are going to do some examples with those so you can sort of, if you forgot maybe, you can get a little bit of practice here. I'm going to zoom in so we see this. So here I have everything being multiplied. When you have things being multiplied, your coefficients will get multiplied just like normal. So that is negative, or 3 times negative 2, okay, which is negative 6. And then you just add all of your exponents. So x is 2 and 3 is 5. Y negative 2 and negative 4 is y to the negative 6. And so this is where we have that example of negative exponents. Because the y has a negative exponent, I will need to draw a fraction line and bring that down. So what it is now is negative 6x to the 5th over y to the positive 6th. You want to be careful. A lot of times kids will try to bring down negative coefficients, and you don't do that. You only need to bring down things that have negative exponents. So the negative 6, even though it's negative, does not change sides because it doesn't have a negative exponent. And this would be your answer right here. Same thing goes for b. Again, you would multiply all your coefficients. 2 times 3 times 5 is 30. And then z, there is a 1 there, so be careful. Z, 1 plus 2, and negative 5 is z to the negative second. And so we have a negative exponent, so this has to come down, which makes it 30 over z to the positive 2. And same, and I mean, C, we could do C also. We're not going to do all of these. Here we have a power, so this does need to go here, and here, and here. The only thing I want to warn you about is a lot of times kids will see this as negative 2 times 2. And that's not the case. This 2 on the outside is an exponent. It's not just a 2. It's not negative 2 times 2. This is negative 2 to the second power. Okay? So negative 2 squared is 4. And I'll keep this in parentheses. A to the multiply that. Power to a power you multiply. And b to the negative 6. And I'll just bring everything else down. And now it just becomes a multiplication problem. You just multiply your coefficients and then add your exponents. 9 times 4 is 36. A, 2 and 10 is 12. 3 and negative 6 is negative 3. And then just like the previous problems, negative exponent you'll bring down making this 36a12 over b to the positive 3rd. And this is all review. Everything we've done so far, you have seen before, done before in either Algebra 1 or a part of it was in last semester. So here you have power of a power to a fraction. Just remember that this exponent goes to everything. One thing that's a little tricky is right here. There is a -1 that's right there because of the negative sign. So this 4 does go to the -1 and the y to the 7th, and here, and here, and here, everything. So -1 to the 4th, -1 times -1 times -1 times -1. You could do that in your calculator if you want to, but it is 1. Okay, multiply these, so it's y to the 28th over. Remember, that's not 2 times 4. That's 2 to the 4th. 2 to the 4th power is 16. And then you have z to the 12 times 4, which is 48. And then y to the 12th. Now, I cannot leave it like this. Because the y's have the same base, I can simplify these. Because this is division, I would subtract the exponents to the bigger side. Since 28 is bigger than 12, I'm going to subtract up. So 28 minus 12 is 16. I don't need the 1 anymore. Y to the 16th over 16z to the 48. Okay. So we can do this, these are all the same types of problems. Again, distribute, simplify, distribute, simplify, and you can go ahead and do those. If you have questions, just let me know, but they're all the same type of problems. So here's the new stuff. And so we practice all those rational roots because we want to get here so we know the rules that apply. The same rules apply even when you're dealing with fractions as exponents. So first thing, for all positive, so just, sorry, going back here, rational exponents. Rational exponents is when your exponent is a fraction. Okay. For all positive real numbers of a, okay, so remember it's a, remember, a to the n power. So for all positive real numbers of a, star here. If n is non-negative, so as long as the exponent is non-negative, then a to the 1 over n equals the nth root of a. So one thing that you're going to understand is that roots, these are called roots, okay, and I'm over here, I'm like off the screen here. Roots, zoom out, okay, there you go. Roots, these are roots right here, this thing here, there's square roots, cube roots, fourth roots, fifth roots, whatever. These are roots. Roots are opposites, are not opposites, but they are fraction exponents. Roots are exponents, they're opposite of each other. So just like squaring a square root cancels, the same thing happens here. When you have an nth root and a fraction, they cancel each other, they're opposites of each other. So a to the 1 over n is the same as the nth root of a. So whatever this fraction is, whether it's 1/4, 1/5, 1/6, 1/7, that n value, the same n value right here, is the nth root of that a by whatever value is here. So you'll see that. And then the other thing is, if m and n are integers, well, and it can't be 0, and n cannot be 0, then a to the m over n equals the nth root of a to the m power. So the definitions obviously may seem a little confusing to you. It'll make a little bit more sense when we actually work through some of these problems. And I keep cutting you off here. There you go. Sorry. So if you have, so this is if you have a fraction that's 1/4 or something like that, or 1/5, where there's a 1 on the top of the fraction. So you can see in these examples, like where you have 1/4, that would match this top one, and it's just this. But when you don't have a 1/4 or whatever that, or you have another number on top other than 1, so like this 4/3 or -3/5, you have to follow the second one. So there's a trick to sort of how we can get it like this. Ultimately, we want to get it into this form because then we know the radical. So how do we do that? Okay, it's easy if it's just 1/4 because then just whatever's in that denominator is the root. So notice how the denominator is the root of that a value. So when we do 16 to the 1/4, all that is, the 4 becomes the root. So the 4 goes into the root just like that. Let me zoom, wrong way. Let me zoom in here so you can see this a little bit better. So see how the denominator becomes the root, okay? And then because there's a 1 on top, it's just that 4th root of 16. Okay? And you can just use your calculator to evaluate that. So I can go over here. Now the trick is sort of, how do we get the 4th root? We have a square root button. How do we get a 4th root button? So it's tricky. With the calculators, you actually, when you have a root that's other than a square root, you need to actually type the root, well, they call it the index. It's called an index. The index first, 4, and then you're going to click the math button. So I can't get zoomed to the right place, but if you look at the math, there's a math button right here. If I click on the math button, you'll see a fraction that has an x fraction. It's got a little x there. You're going to click that. And in the newer calculators, you can see here that I'm trying to get it to where you can see it a little bit better. It's a little dim. In the newer calculators, it'll put the 4th in the root. In the older calculators, it's going to say like 4 and then x root, but it's the same thing. And then I just put 16 and enter. So the 4th root of 16 is just 2. So I could just use my calculator for that. 4th root of 16 is 2. Okay. Now what happens though if we have this 4/3? It's not quite so easy. We can't just put it in the nth root. But what we can do is use our exponent rules. Okay. Use our exponent rules. Can we change this? If I want it to be 1/4, or in this case 1/3, I can change this. 4/3 is the same thing as 1/3 times 4, right? So I can change this root to be 27 to the 1/3 and then to the power of 4, because I know that the exponent rules tell me that by a power to a power, you multiply the exponent. So if 1/3 you would have this 4 would multiply to 4 times 1/3 is 4/3. So ultimately, I get the exponent I want. By changing it to be 1/3, now I can use the initial rule that I had to where my base is just my index. So what this becomes now is the third root of 27 to the 4th power. And I know the third root of 27, or at least I can find the third root of 27 and then do it to the power of 4. So the goal here, when you have a fraction like this, is to get the 1 over that number, and then the whatever's in the numerator will just come out on the outside like this. And this is exactly what that rule was, when we did it right here. So whatever is on the inside became the index, and what was ever in the numerator came out here in the outside the parentheses. So 4/3 becomes just 1/3 times 4, or 1/3 and then to the power of 4, because that's the same as multiplication. This right here is the same as this, because it's multiplication. I would multiply these. Now I know the cube root of 27. Well, at least I can find it. Okay, the cube root of 27. Again, the same way you found the other one. I have to put the index in first because it's not a square root. So I'm gonna put a 3, math, and then go to the x radical there. And so it gives me a cube root, and then I just put 27, and then equals, so you can see it here, 3. So this, just the cube root of 27 is just 3, and then to the 4th. And then I could do 3 to the 4th. 3 times 3 times 3 times 3 is 81. And that's the answer. Okay. For the last one, okay, again, I want to get it into this denominator. This is -3/5, but I want it to be 1/5 so I can do my radical. So we can say that -3/5 is the same thing as 1/5 times -3. So I can just do 32 to the 1/5 and to a power of -3. Because of my exponent rules, multiplication is power of a power. So I just do a power of a power to 1/5 and -3. And now I can just use the rule for the radical that's up here, where my denominator becomes my index. So this becomes the 5th root of 32 to the -3 power. Okay. So now I can do this. I can find the 5th root of 32. So again, I'm going to use my calculator. I have to type the index in first. So 5th root is 5, then math, then go to the x root. So that makes it the 5th root of 32 is 2. 5th root of 32 is 2. So this just becomes 2 to the -3 power, and you might not know that off the top of your head, but you can also do that in the calculator. 2 to the -3 power is 0.125, or I think it's 1/8, but it's 0.125 or 1/8. That's it. Okay. So now, yeah, you probably guessed it, just like in the last lesson, we can't go one way without going the other way. So now we are in radical form, and we want to put it in exponential form. So we went from fractional exponents to radicals. Now we're going to go from radicals to fractional exponents. So we have to remember that 187 will serve as your base. It's in the radical. Remember that the index is the denominator. So this is 187 to the 1/4, and then the exponent out there is to the 3rd. And then we can simply just multiply this. 3 times 1/4 is 3/4. And that's it. Remember, index is denominator. Denominator is index. Okay, in the problems before, denominator, okay, the 4 was the denominator, so it's the index of this number. Here, the index is the denominator, so this is a 4, so this is a 4, 1/4, and then that power is just on the outside. So same thing happens here. The 5 is the denominator, so I have -8, okay, of the 1/5, and then times 8, and then I just multiply. 1/5 times 8 is just 8/5, so -8 to the 8/5 power. Okay. Here again, 4 is the index, so 4 is my denominator of 256, so it's 1/4 to the third. 3 times 1/4 is just 3/4, so 256 to the 3/4 power. That's it. That's nth roots and fractions and as exponents. And so if you have any questions, let me know. But that's it.